In this video, I'm going to explain how this line platformer engine works, the progress that I've made on it so far. So as you can see, there are these lines, and there's a player sprite, and you can drag these lines around like this as the platforms. And the points snap to each other, and there's wall collision against super thin walls like that. There's a couple bugs right now, I need to fix those, but I just want to explain, but most of the bugs are finished, like you can't walk through this. And there's even moving, and you can slip down slopes like that, sort of. And you can walk up slopes, you can walk smoothly down them, which is nice. And moving platforms also work, sort of. I need to change the system of that. But so far it's working pretty well, and I'd like to use this to eventually make a full platformer game. Like in a couple years. It'll probably take, I don't know, because if I work on projects so slowly. But anyway, I like to explain how this works because it might be useful to some people. So the first part is just getting the lines to be dragging like this and snapping to each other, and then you can press 1 and 2 to make a new line, or hover over the point, press 0 to delete the line. So we'll just take a look at the code. So we have this list called lines data, and each line requires 4 numbers, so x1, y1, x2, y2 for this line, and then the same pattern for all the lines. So we first add 2 lines like this. We add the 2 example lines, the demo lines, to the project, or to the list. And then forever we're drawing all the lines. So we need to repeat the number of lines. So the length is 8 here, so 8 divided by 4 is 2 lines. And this is this is like a method to use to repeat through a list. Like you change the line number by 1, and then you want the start item number will be this. So for the first line, it's going to be 0, and then add 1, 2, 3, 4. We're going to get item number 1, item number 2, item number 3, item number 4, and put that in put those values in x1, y1, x2, y2. Then for the second line, we're going to change line number by 1. So this is going to be 2. This is going to be 2 minus 1. Or excuse me, 2 minus 1 is 1 times 4 is 4. So we're going to go to 4, and then 4 plus 1 is 5, 6, 7, 8. So we're going to get item number 5, item number 6, item number 7, item number 8. And then that'll keep changing. So for next, we're going to get number 9, 10, 11, 12, 13, 14, 15, 16. So this is a really good way to loop through the list like that. And then what's going on here? So, yeah, you just draw the line first. So go to the first coordinate, then draw to the second coordinate, and then you check if the mouse is within 10 pixels of the value. Then it'll draw the point, and then also set this variable line hover number point, and then if you click on it while you've set those variables, then it's going to set the grabbed number to that number. Then if it's grabbing, if you're dragging the line like this, then yeah, it's going to modify depending on which point you grabbed. It's going to keep. So if you grab the first point, it's going to keep the second point the same, but change the first point depending on your mouse position. And then once you release it, again, if you were hovering the first point, if you were dragging the first point, then this is it's going to check if you are hovering on another point, then it's going to snap to that one, and either way it's going to replace the line in the correct item number with that new value. And then for drawing lines, again, it'll snap to it, and then once you press the 2 key, it'll let it go, and then when you 0, it'll delete the line. So that's kind of the code for the for making these lines, which is really nice. And then again, you can drag and snap to it, which is nice. Okay, so that's the first part. Then the second part is making it scroll like this, which is mostly similar. So all this code is the same, except we got to add a couple things. So the first thing you need is you need to make these variables cx, cy, and czoom. That's camera x, camera y, and camera zoom. Oh yeah, you can zoom in and out like this with E and Q, which is nice. So you do that, you control it like that, and then so doing the same thing, but for this, every time we use the x and y values, we have to offset it by camera x and y and multiply by zoom. So that's how you get it onto the screen point. So that's how you convert an in-game value, that's how you convert the value in the world into a value on the screen. So this is the original point of the line. The original value of the line point is the line's position in the world, and then we're gonna change it by these variables to make it go on the screen properly, like to position right, depending on the camera X and camera Y and stuff. And then we also gotta have this block clip line at screen edges. So that basically means, because if we don't do this, then you can see it's gonna get screwed up. Like the lines are gonna be broken at the edges. So what this is gonna do is gonna calculate the slope of the line, and then if one of the coordinates is off the edge, then it will first of all set it to the edge and then correct the other coordinate. So this is just using the slope formula and the point slope formula from algebra, and it will display the lines correctly. So that's that. And then a couple other places where you have to add this c-zoom and cx, cy here, 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 and that's it. So that's the second part, doing the getting it to scroll. So then the third part is we added this player sprite, so we split it into two sprites, so we still have all the lines. And then the player sprite, we're going to put the controls in it. We have the player variables now, so px, py is player x and player y. These are going to be player x velocity and player y velocity. We're not really using those yet. P height in this case is just 100. You could set it to 50 and it would be half as tall. Couple other variables here. So do the controls, and then the Y collision, all it's doing, as you can see, if colliding is 1, is just going to change to that neon green color. So all this block does is check if the player is colliding with any of the lines, as you can see, that 0, 1, 0, 1. So how this works is, so first we're using a similar script to the loop script as the drawing of the lines, as you can see this here. So repeat through all the lines divided by 4. There's the change line number by 1, set the start variable and get the x1, y1, x2, y2 of this line. Calculate the slope and then calculate the intersect y, which is basically this y value right here. So depending on the use the slope and the player x to calculate this point. Again, it's using the point slope formula from algebra. And then to check if it's intersecting, you just got to check if the player x is between the two x points of the line. So the player is in range of the line. So here it won't be anymore. So if it's in between the line, like in between the x values of the line, this is just a shortcut formula to do that. If px is between between both of these, no matter the order. And the intersect y is in between the player y. The py is the low point of the player right here. So that's the value of py. And then py plus p height is up here. So if the intersect y is somewhere in between the py and the py plus p height, then that is also true for the X. So X is colliding and the Y is colliding, then the player is colliding with this line. And then we're going to set colliding to 1 and stop the script, and then it'll make it green. So there you go. And then also a couple fancy and for drawing the player, again, you have to take into account the camera X and camera zoom variables to do this, and it'll draw it on the screen in the right place. And then a couple fancy scripts here for changing the zoom. Because if you don't use this E block, it's gonna zoom out really slowly and then zoom in really fast. So to take account for that logarithmic behavior, we're gonna adjust it by the E so that it makes it look more, makes the rate of change look more stable. And then we're gonna cap the C zoom at 2 and 0.2. So right now it's at 2. I can't go any higher than that, and the lowest it can be is 0.2. Yeah, so you can do that with these if blocks. If C zoom is greater than 2, then set to 2. If C zoom is less than 0.2, set to 0.2. You can also do it like this, which is pretty, like, it's like a fancier way, like just takes up a little less space and doesn't use the if block, which is a little bit faster. But again, you don't need that. You can do it either way. This way is more confusing, obviously, but anyway. Okay, so that's part 3. And now finally is part 4, where okay, thank gosh. I thought I wasn't recording the audio. I have to do this all over again. Okay. So part 4 is fully behaving like a platformer, where there's collision and it actually stops the player from, moving down. There's X collision, Y collision, colliding with these thin walls. So it's really nice. So let's try to explain this. So again, we have the player sprite, the line sprite, not much has changed. I tried adding the moving lines script, but again, I'm probably going to change this later. But you just have to get that number of the line and then change its Y position. Like change the Y coordinate of the line. Also, this is a really useful script. I'll just show it. Plus times sign times plus. And then you put timer in the last one. So this is the center. This is the range. So 100 on either side. And the speed. So 360 is 1 cycle in 1 second. And then this you can just leave it blank or put a 1 or a 2 to make it an offset. And this is a really simple oscillation script. So this, if you do this forever, like this, then like I don't have anything. Let's just do that. Then as you can see, it's gonna center at 0. Going 100 on either side, so if I make that 10, the range will be really small. The radius, excuse me. And then 360 is 1 cycle in 1 second, so I make it 180, it'll be half as much. So this is really useful. I use this all the time. So in this case, it is centered at 200 with a radius of 150. And then the sign of the just moving tick is just changing. Okay, so that's for the line. So for the player, we have a much more complicated collision script. Well, the Y collision is like exactly the same. Y collision, like I think nothing has changed. So Y collision is identical. So we have the player velocity. Yes, we're using these player velocity X and Y variables now. Here, let me just get this open. So we're using this PVX and PVY now. And PVY is constantly changing by -1. So that's gravity. It'll keep decreasing the velocity over time. Yep, okay. So the first thing we do, and I typed it all up in this comment up here too, the collision process. I'll try to explain it. So the first thing you do every frame is you change the player's Y position. So for example, if I'm just standing on the ground, I'm still affected by gravity. every frame it's going to run this change PBY by -1. So it's going to push me down. Then it changes my position, and then we check for Y collision. So let's see what it does. So it's just going to check if I collide, and it's going to do that same thing. It's going to find the slope, find the intersect Y, check if it's colliding with any of the lines. As soon as it is, it reports colliding. So in this case, I am colliding on the ground. So it's going to make the neon green. And then depending on the velocity, if I'm moving up, so if your velocity is positive, then it means you're going up, then it would hit the ceiling. We would just directly set the player Y to that Y coordinate, the intersect Y minus the player height. So it positions me right here, which is exactly what I want. And if we hit the floor, then it's just going to set the player Y to the intersect Y. And then you also get this nice effect where you can just set the player slope to the slope of that line, and it's great. So why this system is so great is because, first of all, you avoid using this touching color block or the touching the sprite, like if you had a collision sprite. Not only is that really slow, but then to get out of the floor or get out of the ceiling, get out of the wall, you have to repeat like every frame trying to get out of the floor, the ceiling, the wall, and that you have to do like 10 more calculations every frame, and that's so inefficient. Like, it works for platformers, it's okay, but if you want to do that for like a lot of sprites or a lot of complex stuff going on in the background, it's gonna take up a lot of energy. So this system is nice. You just calculate the lines, and then you just immediately snap out of the line, which is great. Now I run this extra just in case. Like, it does work sometimes. Like, if I draw a line here, like let's say if once I put this line down, it'll try to get me out of the wall or the floor, and then it'll snap me up to there, but then it's going to see that I'm colliding again. So then it's going to run this emergency escape. And that will just spin the player around in circles until they find a place out of the wall. And this is actually code from Griffpatch's Platformer series, which I have the link to the video with the code right there. So you can see exactly how he explains how that code works. Alright, so that's the Y collision, which will work for everything. Like, if I don't run this, you can see I collide on the floors and the ceilings, but not really for the walls and stuff. So that's where the X collision comes in. So the first thing we do before checking the X collision is we store the previous player's X position and Y position before we let me zoom in here. So we store the player's X position and Y position in these variables before we do the collision, because what's going to happen is we're going to check if we're colliding, then it's just going to send us right back to those coordinates. Okay, so let's check, see what happens. How do we check if we're in a wall or whatever? So again, we're looping through all the lines, the same code here and here. We get all the data for this line, get the slope. All right, now here we have to check, split up the code if it's a floor. So if the slope is like less than 10, so like that's a slope of 1, that's 0.5, 1, 2, 4, 8. So like this is still considered a floor. So this would be like a wall, right? The slope is greater than 10. Okay, so if it's less than 10, so if it's a floor, then first we're going to check if the player's is within the X boundaries of this line. That's the same code as from up here, if it's in X boundaries of the line. Then we're going to get the intersect Y, and if we're colliding, so far it's all the same as the Y collision block, but now we're going to check if, now how did I do this again? You could just check if the slope of the line is less than a certain amount. That would actually probably be better than this. Basically it's checking like if we moved really fast, then you still might not want to be able to pop out of the slope. But anyway, if the line's too steep, then we're just gonna, if the line is like this, then we don't really want to be able to walk up it, so it's just gonna send collision 1 back and then go back to the old position. So that's that. But if we can walk up the slope, like if it's like this, then we're going to do the X change, and then we're going to pop out of the wall. So go to the intersect Y, so snap to here. But then what we need to do, and that works most of the time, but then what we need to do is check just in case there's another new ceiling above us. Like in this case, okay, we can go here, good. We can go here, we can go here. Oh, but now we don't want to keep going up. Like imagine if I don't do this. Then you see it's going to cause some glitches. I might get stuck. I might pop up. Something bad's going to happen. So we need to, after we suddenly snap the new position, we've got to check again just in case there's a new ceiling. And then if there is, then we got to stop the script and go back to the old position, because we can't keep going further because there's a ceiling that's blocking us. Okay, so that's good. Now the other thing is, what if we're walking down the slope? Like if we're still in the X boundary, but we're not colliding up into the wall, but we're into the floor, but we're walking down it, down to the left like this. Then we're going to check if the intersect Y is within 8 pixels, like vertically, of the player. Like if the intersect Y is 8 pixels below us and we're already walking down, then we're going to smoothly walk down this slope. Because if we don't have this, so this is how it looks right now, smoothly walking down it. But if we don't do this, then it's going to like skipping down. Oh, what the heck? That was really weird. What is going on? That's really weird. Okay, so this is how the code is right now. We're smoothly walking down. But if we don't do this, oh no, okay. If we don't do this, see, we're like skipping down the slope and it's really annoying. Like, see, like that. Skipping down the slope and it's so annoying. So we should have this code. So again, we're going to snap to the intersect Y, but then we got to check again if there's a new floor underneath us. Then we do another round of Y collision, and if there is a floor, then we can't walk down the floor. We got to just go back up. Okay, so that's all for it's a floor. So we basically do the Y collision and just check if we can go up a slope or down a slope and check for a new ceiling and new floor. That's good. So now here's the complicated part, which is the wall. Colliding with a wall like this. Now the wall is too thin. Like if we tried to check every frame, if we're touching it, then we're just going to go through the wall because the wall is so thin. So what we need to do is first check if the Y coordinates are bounded, like if the player Y is in between the wall like this. Yes, good. Okay, then we have to get the intersect X, and this code I might be making change to it because I think it has a bug, but as of right now it's pretty close. See right there, it was a bug. So the intersect X is either the bottom coordinate of the player or the top coordinate. So in this case, it's the bottom coordinate, right? Because the bottom coordinate is touching the wall. But in this case, it's the top coordinate that's touching the wall. So depending on the slope of the line and the player X, if they're the same sign, like in this case, player X is going to the left, so it's negative. Like player speed, I'm walking to the left, so it's negative. And the slope of the line is also negative. So those have the same sign, so we're going to use the bottom coordinate. But if they have a different sign, like slope is negative but speed's positive, then we're going to use the top coordinate. So that's how that works. And then you check if that intersect X is within the speed that the player went. So you can see how even if I set the speed of the player to like 30, like I'm going super fast, I'm still, oh, okay. So that's bad. Alright, well, hopefully you won't be moving that fast. Oh, I think I see why, because, yeah, we're just going, like, right through the wall. If I make it like this, there you go. Yeah, but see, there's still a glitch, so I still need to figure out what I'm going to do with that. Okay, so yeah, this code isn't perfect. see if I release a part 5 to this, which I will. I'll probably fix it. Okay, so that's pretty much it. So we have the collision there, and yeah, so that should work pretty well for all the dynamic collisions. Like, I checked all these extreme cases, like the sliding down the slopes, walking into ceilings and floors like this, up inside these cusps like that. So it should work pretty well. Again, there's that glitch I have to fix with the X collision, but for the most part, it's working pretty well, and I'm really excited to see how this is gonna keep going. And again, I did make a project with like this for the Tears of the Kingdom project, used a system like this, but it wasn't perfect. It was really complicated, and I want to make it a lot better now. So that's why I'm coding this again. Okay, all right. I hope this explanation helped a little bit, and thanks for watching. Bye. Happy Thanksgiving and Merry Christmas.